Oh. So anyways,
We'll keep that in.
databases are the heart and soul of how your user data is stored. Everything, if it's persistent, ends up in a database. Today, we're going to be talking about how to choose the right one for your app or your project, because this is a super important decision. It can really affect the way that your app is built, the way that the user experience is, how you fetch data from the front end. It factors into a lot. So, Jacob, can you talk a little bit about what a database really is?
Yeah, so a database is an efficient way to store and retrieve data. A lot of people will use the acronym CRUD, where you create.
Read.
Why could I not think that word? I was like, what? Like, I literally just made all these videos for testing for backend stuff. Like, what? So yeah, you have create, read, update, and delete. And so when you're interacting with a database, that's how you're storing your data.
Mm-hmm.
And now there's a whole array of databases. You have your relational databases, you have your NoSQL databases, you have in-memory databases, and then you have like your cloud-based solutions. And that's not even all the options, but those are the major ones.
Kind of the more popular ones.
Yeah. And they all have their strengths, and they all have pros and cons. But at the end of the day, they're just storing data for you.
Yeah, and there's a lot to think about when you're trying to figure out which type of database to use. I mean, there's scalability issues, speed, data complexity, security, cost. You know, all of those important things factor into what should I use, how should I be using it, how often should I be hitting my database. Especially for cloud solutions, cost is a big one.
Yeah, so to get into the first segment, relational databases, they're probably the oldest, most like
tried,
war-tested, mother-approved databases. And what relational databases are is they're based on a structured query language, SQL. And that's for defining and manipulating the data. They're organized into tables with predefined schemas and relationships between the tables. And it's all established using keys. And so popular relational databases are MySQL, Oracle Database, and Microsoft SQL Server.
Not all are created equal.
Not all are created.
Postgres is also.
And Postgres is a big one, and that is one that we use. There's pros and cons to using relational databases, right? And the pros are it's just structured and organized. You're going to have your data integrity and consistency, and you have powerful querying capabilities that are super efficient. So
yeah, and that's where the SQL comes in.
You can get a lot of data quickly, and you can make multiple queries quickly and not really slow things down.
Oh yeah. That's one of the reasons why they're still so popular today is they're really built the original intent behind them was we're going to store all this data in tables. We're going to take tons and tons of data, and SQL exists so that we can take these relations that didn't exist when we collected the data and query them. We're going to hit them and say...
Did we already... I don't remember if we just briefly talked about this before we pressed record, but we should call a table. We should explain. It's like a spreadsheet.
Yeah, we briefly mentioned it before we started.
We didn't mention it when we started though.
No.
Okay. If you wanted to think about what a table looks like, it'd be like a sheet from Excel.
Yeah. And that's basically it. Yeah. You've got this table. It's an Excel sheet.
And multiple columns can be within your table.
Mm-hmm. And basically the idea behind SQL is I can write a query to say, hey, column 3 of sheet 1, I want to know how that matches up to column C of sheet 35. Mm-hmm. And you can write these queries on the fly. You can build them with your backend or request them from the front end, but backend is recommended. And you can build up these relations. That's why it's called a relational database. And you don't have to have those predefined beforehand. And it makes it really handy for looking up random stuff that you didn't think of at the time, or as new data comes in, you build new tables, you want to build new relations. It's really flexible. And the important thing is it's really, really fast, even for super large sets of data. I mean, I've seen tables with literally millions and millions of rows. And so those are just entries, going back to that spreadsheet example. You run a query and it comes back in less than less than 100 milliseconds. Like it just blazingly fast.
It's quick. It's quickie quick.
Yep.
So the querying capabilities are probably number one reason for choosing relational databases. And then you also have ACID transactions. And that is, okay, wait, don't help me. Atomicity.
Yeah, you said it that time.
Consistency, isolation, and durability.
Yes.
Basically, what all that means is it just ensures the integrity of your data through errors, power outages, whatever could happen, right? Your data will be there if it made it there.
Yep.
And so you can rely on data integrity.
It really is a mature and well-established technology. It's been around forever. A lot of developers don't like it that aren't familiar with databases, but they're mostly front-end developers and nobody cares.
I used to be one of those because I learned on MongoDB, which we'll get into. That's a NoSQL database. We'll get into that next, but it was only because I was scared.
Yeah, well, that's how it is with a lot of things.
Yeah.
I mean, with SQL, with C++, for example, it's always, this big scary technology that nobody wants to go and learn because it's hard. And then once you actually learn it, it's like, that wasn't bad.
It turns out it's not that bad. And
actually, it's super useful.
I prefer Postgres now over NoSQL.
Sure. Yeah. I don't think unless I absolutely have to for design purposes, I'm not using NoSQL anymore.
Yeah. I mean, we'll get into reasons why you would, but
yeah.
Now, we said a lot of good things. There are cons to relational databases, and there are scalability limitations.
It can be hard to scale it, especially with more mature tables and as your code base grows and your data sets grow. Because you get into this problem where you have tons and tons of tables all over the place, and it's hard to manage all of them and scale them properly.
Yeah, hard to manage, hard to write migrations for, hard to change.
Yep.
So like when you have huge amounts of data, lots of tables created, it's just hard to make small changes.
That's why you just get it right the first time.
It's super important to plan. It is for sure, right? Like in the early stages of your app creation, you gotta pound that stuff out and make it right.
Yeah.
But you're always going to have changes. It's just, it can be more difficult in this world. And then the next one is a fixed schema. And that's just, you're locking in your data structures.
Yeah. It's a lot more rigid than NoSQL is.
Which I personally don't think that's a con. Because I do think it should be rigid. It prevents a lot of errors.
Yep.
So yeah, relational databases, they offer structure, data integrity, and powerful querying. Those alone are enough to make me very happy. They may face some scalability challenges because they have a fixed schema, and there are some cost considerations to take into account.
Depending on what service you're using, how you're doing that changes.
Yeah.
Because NoSQL can be really spendy too. Another type of database that we mentioned that we're going to cover is NoSQL. And we've mentioned it a couple of times, but basically NoSQL stands for not only SQL. And these databases were designed to handle large volumes of unstructured or semi-structured data. For those familiar with programming, it's basically the difference between here's a statically typed language and here's JavaScript.
You can insert whatever the heck you want.
Yeah. They provide flexible schemas, they allow for easy scalability and high performance, and NoSQL databases can be classified into a bunch of different types, including document databases, which is what MongoDB and Couchbase are, and they store data in a flexible JSON-like document. Another type is a key value store.
Like now that I'm thinking about it, it's like SQL without the rigidness. Like you're not required to make the migrations.
Mm-hmm.
You can just change your schema.
Yes, which can be good,
Yeah.
or it can bite you in the butt.
Because it allows anyone to change
Yep.
your database structure, really. Anyone within the code base. So.
And if you have somebody in JavaScript inserting stuff that shouldn't be there or not including stuff that should be there, and then say iOS or Android goes to access it and they have to define strict types, then it throws all kinds of errors and causes problems.
Mm-hmm.
Another type of NoSQL database is a key value store, and that just stores data as key value pairs. It's super simplistic, but they offer fast retrieval. The problem is it's very limited querying capabilities.
Now, like a good example for what you would use something like this for is like rate limit.
Yeah.
Rate limits against like API hits, where you can have like, okay, this API key has hit this endpoint 100 times in the last minute.
Mm-hmm.
Boom. And it's kind of like memory storage.
Yeah. Yeah. It's super easy to get to.
And it's decently quick.
Yeah.
Depending on for smaller bits of data.
Yeah. And examples of this are Redis and Amazon DynamoDB. There are also columnar databases, and they store data in columns rather than rows. And the benefit there is they're really suitable for analytical workloads. And examples of that are Apache Cassandra and Google Bigtable. So if you're doing data science stuff, that's really helpful. There are also graph databases, which store data in nodes, and edges, which represent relationships between entities, and they're ideal for working with complex interconnections. You see that a lot with things like Google storage or Facebook. The GraphQL was actually a language that was built by Facebook, and it's a framework that works on top of a couple of different types of databases to have these graphs. And the benefit here is, like SQL, you don't have to have a certain relation between anything, where, for example, a document database like Couchbase or MongoDB, you've got objects and everything has a relation predefined to it. The graph lets you just store data all over the place and then connect the dots between them.
You can just point and choose your relationship.
Yeah. And it makes it really easy to use and really nice to use. I still prefer SQL, but it's not a bad option. And some examples of that are Neo4j and Amazon Neptune.
So yeah, that's actually that's a big chunk of the NoSQL databases. I think that covers most cases. So like pros with this are scalability and performance because of the unstructured data.
Mm-hmm.
So it allows, like, a lot of startups will like this if they're constantly changing and figuring out.
Oh yeah, it's great for if you have no idea what's going on yet and you don't have a solid plan.
Yep, and then that leads into like flexible schema for creating just easy data models and architecture. You know, honestly, they're great databases to get started on.
Yeah,
because like querying and getting data, it all ends up working the same way, and it's like training wheels for a relational database.
Yeah, and you can use them. They could be really helpful while you're still structuring your data and, like you said, getting started and getting your product going. And that's one of the reasons it's important to have a separation between the front end and the back end. A lot of the problem comes in when front ends, clients like your web page or your iOS app or your Android app, they are directly calling the database. That can cause a lot of problems because, say you decided to switch databases after you got everything solid and you have that plan and everything's more structured, you now have to go update all your clients.
Yeah, you need the separation of interest.
Yeah. And if you hold on to that properly in the back end and keep that interest there, the back end can make that switch and the front end will never know.
Yeah.
And so you want to make sure that you have those separation of interests and responsibilities for those kinds of reasons. I've just had a lot of clients who decide I'm using Firebase or whatever.
Yeah.
And everything is done in the client.
and then you're tightly coupled.
Yeah, and it's a pain to make any changes.
You're rewriting your app and making a back end.
Yep.
If you're ever changing or moving away from Firebase.
Yep. So it's not a bad idea to use them to start. And even after you start, if you're good with the risks, then great.
Yeah.
But like I said, one of the biggest risks is where there's no structure, there's a lot of risk for errors.
Yeah. And there's also a big lack of standardization among these languages, because a lot of them are startups themselves.
Yeah.
So they're not like relational databases have just been that way for so long. Everyone follows the protocols. And so NoSQL databases, they all kind of do their own thing because they think they're doing it better.
Yeah.
Which, I mean, from my experience, like CouchDB and MongoDB, those are really, I have done DynamoDB. That's the Dynamo. That's the AWS one, and they all work. I mean, they have their quirks and they're a little differences, but for the most part, if you can read documentation, you're gonna figure them all out pretty quickly.
Yeah.
Let's see some more pros. High availability and fault tolerance. Their horizontal scalability. That's always important. So, that's spreading them across multiple servers.
Yeah, as you add more hardware, it scales across the board. And it's easy to manage that.
And suitable for handling complex relationships in graph data.
There are a few drawbacks to it, though, like lack of standardization, like we talked about a little bit, and varied query languages. That can be a major pain. There's also limited support for complex transactions and joins. For example, with Firebase, again, because I just ran into this a few weeks ago and it drove me nuts. To do a query that involved more than 2 parameters, like 2 variables, you had to predefine the query. And you had to go set that up in Firebase's console. I couldn't call it from the app. I had to go to the console, set it up in Firebase, wait for it to compile, wait for it to set up indexes, and it has to be set up for each variation of that, meaning I was looking for something with an archived flag and I wanted the archived flag to be descending. And as soon as I tapped the button to switch it to ascending, I had to go and set up a whole new index and wait for it to compile and all that stuff. And it was a pain in the ass.
I hate things that you have to use dashboard tooling for. Yeah. Like you should just be able to write a query.
So that kind of stuff, again, SQL, that's one of the reasons I prefer it, is it's built for that.
Yeah.
There's also a lot of data redundancy due to denormalization of things. It's easy to have multiple entries for the same thing and data to get all mucky and murky and have problems managing that. So you have to be really careful with them. They're also not really suitable for applications that require strong data consistency guarantees like we talked about, because errors get thrown. You've got this random bug because the web client didn't add one parameter to this one entry.
And what's nice is relational databases will throw errors for you too.
Yep.
Based off
when you're writing it.
Right.
Right. That's the difference is the SQL database will go and throw an error and say, hey, you forgot this parameter.
Yeah.
And the NoSQL database will say, okay, that's cool, I'll put it in there.
Yeah.
And then when a strongly typed client goes to read from it, you'll just get client-side errors saying, hey, it crashed. We couldn't create this object.
Well, or you sit there and you just check for nil across everything. And so you have really nasty,
redundant code.
Yeah.
It's bad.
Yeah, exactly. So NoSQL databases, they provide scalability, flexibility, and high availability for unstructured data, but they lack in standardization. They also have limited support for complex transactions, and they require trade-offs between consistency and redundancy.
Yeah.
So honestly, that doesn't sound very good, right? At least not to me.
Not great.
But overall, I think if you have your data architecture ironed out and good, you want to go with a relational database.
Yeah.
All right. And then we all have our in-memory databases, and they store data primarily in system memory. So this just makes for faster data retrieval and processing to disk-based. It makes for faster data retrieval compared to querying databases. They're useful for applications that need a lot of real-time data processing and high-speed analytics. I'm not too familiar with any in-memory databases, to be honest, except for like caching services.
Mm-hmm.
And so I don't have much to say about this. I'm going to let you go.
That's fair. There are a lot of pros and cons.
I'm a back-end guy.
There are a lot of pros and cons for in-memory databases. Sorry, I got distracted.
You're good. He's worried about his kids or something.
Jeez.
He hears a weird noise and he's like,
is someone dying?
Themselves?
So there are a lot of pros and cons to in-memory databases. Some of the benefits are fast data access and processing, and that's because the data resides primarily in memory. It's also really high performance for real-time applications and analytics, and there's a reduced disk I/O latency compared to disk-based databases, and that's just because of how things are stored, and on a physics level, disk-based is slower than, for example, solid-state drives and flash anything. It's really well suited for handling high-velocity data and workloads, and it's got really improved scalability and responsiveness for time-critical applications. So if you've got something that you don't need deep data for, and you want it fast, in-memory is a really good option. Some of the cons of in-memory databases are there's a higher cost due to the need for more memory resources. They're not all that efficient. And there's a lot of limitations to the capabilities compared to disk-based databases like SQL, for example. And the data durability is also a concern because it's using volatile memory RAM, for anybody familiar with that. And there are a lot of challenges in handling data persistence during system failures. So it's not terribly persistent. Going back to that ACID example, the durability is pretty low. Mm-hmm. And there's a lot of risk there. It also potentially requires more advanced caching and data eviction strategies, but that's kind of an edge case there.
And everything's sitting locally.
Yeah, everything's sitting locally.
So they're usually not used alone either.
No.
Because you need.
They're usually like a supplemental thing to a more durable database. It's more of like caching and, hey, I need this data quick and I need it available locally for now, kind of thing.
Yeah, I would say my only experience, and I don't even know if, I guess it would fall into this, but like supporting like offline support and have your app still function.
That's essentially what it is.
You have to hold data and things at least,
Yeah, so when you're using database technologies and frameworks where your database is living on the cloud somewhere on your server and it works offline with the last known version of the database, that's just caching. And that's just in-memory databases supplementing that server-side database. So in-memory databases provide fast data access, high-performance processing, and improved scalability for real-time applications. But they have higher costs, limited capacity, and there are a lot of challenges with their durability. Mm-hmm. I don't usually recommend that they're used alone in any way, shape, or form.
Because you never want your front-end app doing the power
to be
the powerhouse of your product.
Yeah, you want the front end as dumb as possible.
Yeah, your like front end is a display. You plug it in and it just shows you things.
Yeah, basically. So there is also another type of database, which is cloud-based databases. And this refers to databases that are hosted and managed in a cloud computing environment. And instead of running on local servers or infrastructure, these databases are provided as a service over the internet.
So these can be any of the databases we mentioned already, but provided through services like AWS,
AWS,
IBM, or DigitalOcean, Like you're basically
Azure
SSHing.
Cloud Services.
That's what I meant.
Yeah.
That's the Microsoft one, right?
Yeah.
That's what I meant when I said IBM.
Well, there's IBM Cloud too.
Is there?
So yeah.
Oh, okay. I wasn't completely wrong.
Nope. You're just missing Azure, but we don't personally use those services.
Well, I don't use any of these services because I like to control our own environments in Docker containers, but we'll still talk about them like they're really cool.
Yeah.
One thing that's nice with like cloud-based solutions like this is it's kind of like a low barrier to entry. You don't really have to understand them that much. Like scaling and everything is usually handled by the service.
Elasticity.
Yeah. So, but the scary thing about that is if you go viral overnight, you can have very expensive server costs.
There are all kinds of horror stories about $100,000 AWS bills.
Yeah. But the ease of use and integration, you're up and running really quick. So that's always really cool. So yeah, you have scalability and elasticity. I feel like I can't say that word. You have the high availability and fault tolerance because it's just built into replication and data redundancy mechanisms through these services. And then they also simplify your database management. They usually, provide automatic backups, updates, and patches, so you don't have to worry about keeping your database up to date. Someone's doing it for you. He's not happy with cloud-based services.
Flynn does not approve.
So a lot of people find them cost-effective because they're pay-as-you-go, but there's also a little scariness to pay-as-you-go.
Yeah.
Going viral overnight can put you out of business overnight.
Right.
We actually know some people that woke up to like $250,000 bill using AWS services.
Yeah. So you got to be careful with them and make sure that you've got the proper stop gaps in place of I can't afford this.
So I guess that's a con. I was kind of reading off pros. Surprise $250,000 bills. That's a con.
Most people don't like those.
And some other cons are you're usually required a dependency to interact with them. Mm-hmm. So you're using another third-party library.
Some kind of SDK that you have to implement.
Exactly, which makes it easy, but it's just another thing you have to rely on.
Well, and it also ties you down to whatever platform you pick.
Yep. And then you also have limited control and customization. Like you normally can't add like table prefixes and things like that, which allows you to use the same database with multiple, like with controlling access to data. And controlling access to certain organizations or accounts is super important, at least in a lot of work that we do. Yeah,
for sure. There are also a lot of potential concerns around data security and privacy due to the data being stored in the cloud and you don't own it.
Multi-tenant is the word I was looking for.
Yes.
And they usually won't support that.
There's also really limited control and customization, like you were talking about a little bit, compared to self-hosted databases. It's kind of a here are your options, deal with it thing instead of being able to customize it.
And in most people's situations, it's okay. You usually don't need to unless you're doing cooler things.
If you're just doing here's my app, then you're probably fine.
Yeah. But if you're like me, I always putz and just add complexity to our projects to make them cooler.
To make himself feel smart.
Yeah. I mean, you do feel smart. So cloud-based databases, they offer scalability, high availability, simplified management, and cost effectiveness. However, they may require reliable internet connectivity. They could raise data security concerns. They limit control and customization options. And they present potential vendor lock-in risks, which we kind of talked about, like with Firebase, you're locked in, or
you're stuck to whatever
when
platform.
You're using an SDK, like you can't easily migrate your data.
Yep.
And there could be performance fluctuations because you're in a shared environment.
Yeah.
With other companies is what I'm saying.
Yeah. You have options for here's my dedicated server with a lot of them, but most of the time you're stuck with you're sharing this processor with whoever.
So mistakes that are commonly made when choosing your database, like I'm sure we just rattle off a lot of shit that you don't.
There was
really
a lot of
understand.
heavy info in there.
But common mistakes and what you should avoid is just not understanding your requirements.
Yeah.
You need to understand what your app needs to be able to do.
Yeah. You need to understand what you're trying to build before you can pick. You also need to, another common mistake is ignoring your future growth and scalability with that choice.
Mm-hmm.
You have to decide, how likely am I to need to scale? How likely am I to need to change data, deal with schemas, all that stuff? It's important to consider that when picking.
Yeah, and you don't want to overlook performance considerations.
Mm-hmm.
If your app requires speed, but you have to query a large amount of data, you're going to want to be in a relational database.
Yeah, exactly. And you also don't want to disregard data modeling or schema design.
This is the most important part. Even before you pick a database,
Oh, absolutely.
You should at least know your data architecture.
Have some kind of structure as to what you need, how you need it.
Obviously, relationships between tables will change slightly depending if you go with like a NoSQL versus a relational database. But for the most part,
the overall structure you can do before you pick.
Exactly. You don't want to neglect data integrity and consistency. So if it's super important to keep data integrity, which it normally is,
most people think
want to choose the proper technology behind your requirements.
Yeah, and you also don't want to underestimate maintenance and operational overhead. You want to look at your options and see the costs.
Like if you're going to go viral overnight, don't use a microservice.
Well, everybody thinks they're going to go viral overnight.
That's true. So just to be safe, don't use a microservice.
Don't use microservices. There we go.
You don't want to rely solely on trends or popularity. We talk about popularity all the time.
Oh, yeah.
Like, why is React so popular? Why is Node.js and Express so popular? Like, and everyone chooses these technologies because they're popular.
Everybody else is using them, and so they're safe.
Which is why everyone jumps on NoSQL databases because they're popular at the moment. And also, like the services, the cloud-based services.
Yeah, but popular in no way, shape, or form makes it right.
No. So don't do it because the cool kids are doing it. Do it because it fits your needs.
Yeah. And also on that same note, you do want to make sure you're considering ecosystem and support. We rail against don't pick it just because it's popular, but you want to make sure that it's battle tested and that it's not going to bite you because
and
it's
mother
brand
approved.
New. Yes. I remember my grandmother's recipes of relational databases.
Exactly. So avoiding these mistakes involves understanding your requirements, planning your growth, considering the performance you require, and designing your data models carefully.
Yeah.
Like designing your data models is the most important element to your app before you start. And then you care about your data integrity, evaluating your maintenance needs, and just you have to make informed choices and just choose what works the best for you.
Absolutely.
What works the best for us might not always work the best for other companies.
Make smart choices.
Make smart choices and just realize you have a lot of options. It can be overwhelming, but don't rush this piece of your project.
Yeah, and if you need technical help, reach out to somebody.
Reach out to someone, hiredgunapps.com. We're always here. We'll even build it for you, and we'll make sure your product is scalable and reliable.
It's what we do.
And consistent and fast, because it is what we do. Bang, bang.